Welcome to our channel. Let us learn the logical connectives and their truth tables. First one, negation. If P is a statement, then negation is denoted as not P, like this. If P is true, then not P is false. If P is false, then not P is true. So remember, this is not P. For that, we have to change P to F and F to P. Second, conjunction. There are two statements, P and Q. If we have two statements, then there are four possibilities. That is TT, TF, FT, FF. The conjunction is denoted like this, P and Q. If both are true, then the answer is true. Otherwise, false. So remember P and Q. If both are true, then true. Otherwise, false. Third, disjunction. There are two statements, P, Q, so we have four possibilities, TT, TF, FT, FF. P or Q, so the disjunction is denoted as P or Q, like this. Here, the condition is if both are false, then the answer is false. Otherwise, true. So remember, for P or Q, if both are false, then answer is false. Otherwise, true. Next, fourth one, conditional statement. Consider two statements, P, Q, that is TT, TF, FT, FF. The conditional is denoted like this, P, then Q. Single arrow mark, we say that P, then Q. Here, the first statement true, second statement false, then the answer is false, otherwise true. Here, the first statement is P, so P is true. Second statement, Q, is false. Then we get the answer false, otherwise true. So P then Q, we can remember like this easily. PF, then the answer is F. That is first true, second false, then the answer is false, otherwise true. Next, fifth, biconditional. Here also we have two statements, P, Q and four possibilities, TT, DF, FT, FF. The biconditional is denoted like this, P, if and only if, Q. So double side arrow mark, we say that if and only if. Here the condition is if both are same, then the answer is true. Otherwise, false. Both are same means. See the first row. True, true, then the answer is true. See the last row, F, F, same, then the answer is true. Otherwise, false. So the biconditional, P, if and only if, Q, we can remember like this. If both are same, then the answer is true. Otherwise, false. And sixth, exclusive OR. Here also, we have two statements, P, Q, and four possibilities, TT, DF, FT, FF. The exclusive OR is denoted like this, P, X, or Q. Here, the condition is, if both are same, then the answer is false. Otherwise, true. See the first row, TT same. Last row, FF same. So for that, we have to put the answer false. Otherwise, true. So remember, PX or Q. The condition is, if both are same, then false. Otherwise, true. So these six are the logical connectives. We use it in problems. And in the truth tables. Finally, if we get all the answers true, then we say that it's a tautology. In the truth table, if the final answers are false, then we say that it's a contradiction. If we have both mixed true and false, then we say that it is a contingency. Now let us see the problems. Construct a truth table for not P and not Q. Now we have to draw the truth table, and we have to use the conditions. Instead of remembering all the tables, it is very easy if you remember these conditions. Now we have to take two statements, P, Q. We know that there are four possibilities, TT, TF, FT, FF. Here, see the question and draw the table. In the question, first we have not P. So in the table, also we have to take not P. In the question next, we have not Q. So in the table also next to take, not Q, and the final column, see the question and take and write it, not P and not Q. Now we have to find not P. Not means change T to F and F to T. So see the statement P, just change T to F and F to T. So first one, T, we have to change it as F. Second, T, change it to F. Third, F, change it to T. Fourth, also F, change it to T. So this is negation, not P. Similarly, next column, not Q. We have Q. Here also we have to use negation, not Q. So see the statement Q, change T to F and F to T. So, first one, T change it to F. Second, F change it to T. Third, T change it to F. Fourth, F change it to T. And now finally not P and not Q. For these two, we have to take and. P and Q means both true, then answer true, otherwise false. So to take and for these two, we can use the condition very easily like this. If both are true, then the answer is true. Check in these statements whether we have both true. Only in the final row we have both true. So for that we have to write true. So both true means answer true, otherwise false. So for all the remaining, we can write false, F. So this is the final answer, FF, FT. Similarly, next sum, construct a truth table for negation of P and not Q. So here also, there are two statements, P, Q, T. So we have to take four possibilities, TT, TF, FT, FF. So in the question we have not Q, so in the table also write not Q, and then take this bracket P and not Q, and finally negation of P and not Q. Here, first one, not Q. We have the statement Q. Not Q means just change T to F and F to T. So first this T, change it to F. Second, F, change it to T. Third, T, change it to F. Fourth, F, change it to T. Next, P and not Q. So these two we have to connect using and. Note that and means both true, then true, otherwise false. So in these two columns, check whether we have both true. Only in the second row we have both true, so for that the answer is true, otherwise false. So all the remaining false, we can write F, and finally not bracket P and not Q. So this, we have to change T to F and F to T. So here, F change it to T, next T, change it to F, and then F change it to T, and finally F change it to T. So this is the final answer, T, F, T, T. Similarly next, construct a truth table for P or Q or not Q. So remember these conditions. We can draw the truth table very easily. P, Q, two statements. So there are four possibilities, TT, TF, FT, FF. See the question and take the table. First bracket, P or Q. Next, not Q. And finally question P or Q or not Q. P or Q. That means both false, then answer false, otherwise true. So check whether we have both false. Only in the last row we have both false. For that the answer is false, otherwise true. So all other answers true, next column not Q. So see the statement Q change T to F. F to T, so T to F. Second F to T. Third, T to F. Fourth, F to T. Now these two we have to connect using OR. Again, for OR we have the condition. If both false, then answer false, otherwise true. So check in these two columns whether we have both false. We don't have both false. That means all the answers are true. So the final answer, TTPT. Next one, construct the two table for PXRQ and PXR not Q. We take P, Q two statements and four possibilities TTTFF, TFF. See the question and take the table. So take not Q, and then first bracket PXRQ, and then second bracket PXR, not Q, and finally take this question. First, not Q means we have the statement Q, just change T to F and F to T. Next, PXRQ. PXRQ means if both same, then answer false, otherwise true. So check these two. Both same means first row and last row. For that, we have to write F first row, last row we have same. So for that, we have to put F otherwise true. So other two answers, true T. Next, PXR not Q. So for these two, we have to take XR. So check in these two columns whether we have same so second row and third row same. For that, we have to write F, others true. So other two answer T. Finally, for these two, we have to connect using AND. And we know that AND means P, and Q means both true then true, otherwise false. So check in these two columns whether we have both true. We don't have both true. That means all the answers are false. So we write all the answers false. So the final answer, FF, FF, F. Similarly, we can construct the truth table even for three statements. PQR, see the question here. We have three statements PQR. If we have three statements, then there are 8 possibilities. These are the 8 different possibilities. This we can remember very easily. For that, there is one shortcut method. First column write 4 times T, and then 4 times F. Second column write 2 times T, and then 2 times F, 2 times T, 2 times F. Third column write single TF, 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 TF. In this way, we can get all the 8 different possibilities. Now we have to form the table, see the question, and take and write the informations that is not P, and then first bracket, not P, then R, and then second bracket P, if, and only if. Q, and finally, take the question. Now, not P means see the statement P change T to F, F to T. So first column change T to F. So first 4 change T to F. Next 4 change F to T. Next not P then R. So these two we have to use conditional statement. See the conditional statement P then Q, first true, second false. Then the answer is false, otherwise true. So here not P then R first, not P first, true, second false. That is only these two first true, second false. Here also this first true, second false. Then the answer is false, here first statement, not P, so first true, second false. We get the answer false, otherwise true. So all other answers true. Next column, P if and only if Q. P if and only if Q means both same, then true, otherwise false. So see the statements P, Q, and check whether we have both same. So both same we have in first row, second row, and then last 2 rows. For both same we write true TT, TT, all others false. And finally these two, we have to connect using AND. And note that AND means both true, then answer true, otherwise false. So in these 2 columns, check whether we have both true. We have both true first, second, and last before. So for that we write the answers true, otherwise false. So all other answers false. So finally we get the answer TT, FF, FF, TF. Thanks for watching.